Hi everyone, in this video I'm working through question 13 part C of the 2020 North Sydney Boys High Extension 2 trial exam. So this is a 4-part question, so as usual I'll work through each part in separate videos. So in this first video I'll focus on part 1. The setup of the question is we're told to consider the function fx equals the square root of x bracket 2 minus x, and then we're given this diagram below. And then part 1 wants us to evaluate the integral from 0 to 2 of fx dx. So yeah, let's take a look. So here I've just written up the function we're dealing with and recreated our chart. And we want to evaluate this integral. Now, if you want to jump straight into this, I guess the wrong way to go is just to say, okay, well that's just equal to the integral from 0 to 2 of the square root of x bracket 2 minus x dx, and then try and work out that integral, because you'll discover very quickly that the techniques required to integrate something like this, they get pretty messy, and I'm not even sure that you learn all the techniques you'd need in the Extension 2 syllabus. But the good news is you actually don't need to worry about that. There is a much simpler way, and the simpler way is just to go back to the basics of integration, where we learned that the integral between 2 points in relation to a curve is simply the area under that curve. So hopefully what you can see here is that what we're dealing with is a semicircle, which by definition is half of a circle. So if we can find the area of the whole circle, then we divide it by 2 and we've got our answer. So given this first part was only worth 1 mark, if in the context of an exam you started going down this route and finding that you're doing a lot of work and it's really hard, maybe the hint is that you should pause and think if there's an easier way, because really you shouldn't have to do that much work for just 1 mark. So what we're going to do is we're going to basically find the area of this curve. And so maybe what I'll do is I'll just note that this is the area beneath the semicircle, and hopefully that makes clear to someone who's marking this that you've made the link, that you're not just trying to do the brute force integration. Now the area beneath a semicircle is, as I mentioned, half times the area of the whole circle, and the whole circle, the formula for the area of a circle is pi r squared. So we've got pi, and now we just need to think about what is the radius of this whole circle. And you can see that the circle goes from 0 to 2, so naturally the midpoint is going to be here at 1. To get from 1 to 2 is just 1. You can see that going there. You can also see getting from 0 up to 1. Clearly the radius is 1, so it's pi times 1 squared, which is just pi times 1. So we end up with pi on 2 being our answer. So there you have it. I mean, not much working at all. Once you make that link that we're not actually having to do the integral, we're doing integration, but just by going back to the definition of what an integral is. So hopefully that makes sense and you followed along there, and that's something you could now do if you encountered something similar on an exam. I think the hint is, first of all, it's only worth 1 mark. And also they told us to integrate the fx. They didn't actually put in the function inside the integrand, and maybe that's their very subtle way of hinting, hey, don't integrate it, you don't need to, just think about it as the area under the curve. So that's it for part 1. What I'll do now is I'll move on to part 2, where I got to say I think the question really starts to get quite interesting and quite complex actually. So yeah, tick boom.